friends, in last few classes we discussed about role of data analytics in various decisions related to inventory management. We discussed different cases where we saw that how in variety of situations where we need to manage inventory, and most of the cases are related to uncertainty, and in uncertainty also there are different types of possibilities, whether you have single opportunity of procurement, whether demand is lost in a cyclic system or demand is backlogged. And we saw that if we can improve the quality of our data, if we can improve our forecast, we can reduce the values of sigmas, we will have better cycle service labels, we will have better expected profit. So, as I said in the beginning of the course also, quality of data plays very important role in all analytical related decisions. If quality of data is inferior, whatever type of algorithms you apply, the results will not be so impressive. So, we need to focus a lot on improving the quality of data, because the quality of data is going to decide whether you are going to get a good decision or not. Moving further, in this particular session class, we are going to discuss another very important aspect of inventory management. Now, all the inventory decisions which we were taking in the previous few classes can be classified under independent inventory systems. You have requirement of the item, and that requirement of the item is not dependent on any other item. But we know in reality there are large number of examples. Almost all the products are dependent on the demand of some other product, and therefore, in our discussions of inventory management, it is, you can say, just 50% that inventories are decided on independent basis. But in variety of other cases, inventories are decided based on the requirement of some parent item, and for that purpose another very important decision making areas are material requirement planning. So, in this particular class and for next two more classes, we will be talking about this material requirement planning, which is practically I personally feel is more used area of inventory related areas than the independent inventory management. Now, in this particular case, we are going to discuss about what is MRP, its benefits, why we do MRP, how are we creating MRP, and then what is the structure of a MRP system. In this case, let us first understand that MRP is basically a computational technique that converts a particular master schedule for end products into a detailed plan for the raw materials, components used in the end products. You understand that every product requires so many components, sub-assemblies. You take example of a car. Now, in the car you have around 10,000 plus different types of components and sub-assemblies. You have tires, you have gear assemblies, you have steering assemblies, then you have engine, and in engine also there are so many components and sub-assemblies. So, for making a car, you require all these components at the right time, and then only you can deliver a car. Consider a simple table, a simple wooden table. Now, in that simple wooden table also you have 4 legs, a top, and maybe a drawer also. So, you require 4 legs, a top, a drawer, then only you will be able to make a table. So, for this parent product table, you require so many components, sub-assemblies, etc. So, planning for these components and sub-assemblies, that these components and sub-assemblies are available to me at the right time, that is our MRP. Now, when you are planning for all these component sub-assemblies, each item must be ordered and delivered to meet your master schedule for final products. I need table, table is my product. I need table in the month of July. Colleges are going to open in the month of July and I need tables at that time. Now, for delivering the tables in July, maybe I need to have legs in the month of June, and then there may be a lead time for making the legs. So, the order of that should come in the month of May. Then only the legs will be delivered in the month of June, and then these will be used in assembling them into a table, and that table will be delivered in the month of July. So, you see that to achieve this master schedule for final product, that table is required in the month of July. The component work, sub-assembly work has started in the month of May itself. So, this is the reason, purpose of MRP. Otherwise, you may not be able to deliver. You can easily understand there are always some kind of firefighting which happens, and that firefighting will ultimately lead in delaying in the delivery of this table in the month of July. It will slip to the month of August. So, to minimize, to avoid all such kind of unnecessary delay and unnecessary holding of the inventory of the components, if you do not know that you are going to deliver in the month of July and you have procured the legs in the month of the April. Now, for 3 months, April, May, June, you are holding the inventory of legs, which is also adding to your inventory holding cost, which is also taking your space, and there are possibilities that some of these legs may get let us say some wear and tear also takes place. So, all these are the challenges if you do not follow a proper MRP system in your organization. So, MRP is as I already said, independent and dependent demand. So, this is what we are discussing. MRP, it is part of dependent demand, and all these items which are part of some final product, they are having the dependent demand. If you remember our supply chain discussions, where this is OEM, original equipment manufacturer, and these are component suppliers to OEM. These are designated as T1, T2, T3 etc. Tier 1, Tier 2, Tier 3 suppliers, and these OEM is making end product, and these are making components or sub-assemblies. Now, these component sub-assemblies need to be made as per the schedule provided by OEM, and therefore, the role of dependent demand system is very much for all the members who are part of this supply chain, because they have to follow the given schedule, then only the OEM will be able to deliver the products to the customer as per the delivery systems. Then there comes the wholesaler, retailer on this other side of the supply chain. So, this dependent demand is very much useful for all the upstream members in your supply chain. Here, when you have the forecasting available of the end products for a particular organization, the raw material, the component parts used in the end product should not be forecasted. If you have independent forecast for all these components, then the MRP will not be possible. So, for MRP to execute, only the forecasting of end products is required, and the forecasting of all these dependent items, components, sub-assemblies should not be there. Once the delivery schedule for the end products is established, the requirement for components or raw material can be directly calculated based on lead time. If you have this lead time calculations available for all of them, then you can directly calculate what is the delivery schedule, what is the requirement, and there is no need of separate calculation of any kind of inventory requirement for these components. And you can see in the form of this diagram that how all these things are actually flowing. Let me give you the idea that inventory management, which we discussed in our large number of previous classes, this inventory management actually gives us the concept of MRP, material requirement planning, which is talking of components and sub-assemblies. Then people thought that there may be other kind of resources also which are required for manufacturing of these final products. Not only final products, but these components and sub-assemblies also. And for that purpose, for example, time available on a machine, for example, amount of labor required, these are other resources which are required for making the product at the right time. You are planning that, okay, I will do the manufacturing of the legs in the month of June, but in the month of June machine space is not available. In month of June labor is not available, then how will you make those products? So, therefore, for success of MRP, more manufacturing resources are required. So, people started talking of manufacturing resource planning. So, now MRP and this also is MRP. So, to distinguish between material requirement planning and manufacturing resource planning, MRP is designated as MRP 1 and manufacturing resource planning is designated as MRP 2. Now, MRP 1 and MRP 2, further people said that for all these resources you need enterprise wide support, you need finance also. If capital is not available, working capital is not available, you cannot manufacture the products. So, slowly and slowly the scope went to the organization wide resources, and then the term ERP, which I hope most of you are quite aware, enterprise resource planning, came into existence. So, from our standard management of inventory for independent demand, that how we move to discuss about dependent demands, and in that also more and more resources requirement was visualized, and we started with MRP 1 to MRP 2 to ERP. Now, in this particular class or even in this course, our focus is only on this MRP, and for MRP you have a master schedule. That master schedule is when to deliver which product, and this comes from your forecast requirement. Now, for MRP the important inputs are master schedule, bill of material, that for making one product what type of components etc. you require. I will be talking about that also. And then inventory records, how much of those components are already available in your warehouse, in your stores. So, these are the three important inputs for preparing your MRP. And then from this you are going to create MRP computer programs, and which will give you the when you are going to release a new order, when you are going to place schedule a new order. That is the important outcome, that placing the order at the right time, so that you can anticipate the delivery of that order when you are requiring that order in your final assembly. And based on the MRP output, you are able to increase, decrease your inventory levels. So, your inventory record is created because of MRP output. You know that how much inventory I have, how many orders I have released, and when these orders are expected. So, accordingly you have a clear picture in front of you. Many a time when we talk in supply chain, I will like to tell you that we become myopic about inventories which are in pipeline. We only see that inventory which is physically available in our stores, but there may be some inventory which is in pipeline for which you have already released the orders, but somehow unfortunately we are not able to understand. Because of data, probably we should have a better understanding that how you are able to visualize the inventory which is in the pipeline also. So, with the help of MRP, you are able to reduce your unnecessary inventory. You see inventory in physical plus pipeline. All that inventory you are able to see, and therefore, you give order with very careful with all your mathematical calculations. You are able to respond to changes in demand than is possible with a manual requirement planning system, because you know that you are able to see in a paper that which inventory is at which stage, and accordingly it is easier to manage the changes than the manual systems. Reduce setup and product changeover cost, better machine utilization, the ability to easily determine inventory uses by black flushing, and improved capacity to respond to changes in the master schedule, and it helps you in developing a more realistic master schedule. For MRP, as I said, there are three very important inputs. One is the master schedule, second is bill of material, and third is inventory required. These are the three most important inputs. And then with the help of these inputs, we will prepare our MRP records. So, you can see that for a MRP, the structure is like we have master production schedule, inventory required, and bill of material, and the output is these three are in. This is output, where you are planning the release of orders when you are going to purchase or when you start manufacturing of some of these components. Just to give you the idea of one or two important things which are going to be there in making the MRP bill of material. Bill of material starts with our product structure. Let me give you a very small case where I want to make a product A. You can say it is end product. Now, for making product A, I require two items B and C. One A needs 2 units of B and 3 units of C. 1A requires, so you can write in such a manner that 1 unit of A requires 2 units of B and 3 units of C. Now, for making 1B, you need 1 unit of C and 2 units of D. So, you can say that B has 1 unit and this requires C 1 and D 2. For making 1 unit of B, you require 1 C and 2 D. And 1C needs 2 units of D and 2 units of E. So, 1C needs 2 units of D and 2 units of E. So, now the simple question is, how many B, C, D, E are needed for 1 unit of A. So, this is first require the understanding of product structure, that we know that for these are sub assemblies. B becomes one sub assembly and C becomes another sub assembly. So, you can very easily calculate that 1A requires 2B and 1A requires 3C. Now, 1B requires 1C and 2D. So, 2B equals to 2C plus 4D. 3Cs will require 6Ds plus 6Es. So, the answer becomes for 1A you need 2B, 3C, and then you see that 4D and 6D, total 10 Ds are needed and 6 Es. But now you see this is not complete. You require Cs, here also 2 Cs. So, 2C means how many Ds? It means 4D and 4E also. So, basically you require 1A needs 2B and 3 Cs, while you require 4 plus 4 8 plus 6 14D and 6E. So, you actually require 14D and 6E. Out of 14D, some Ds will go for making B and some Ds will go for making Cs and some Es will also go for making some Bs, and some you will take out of 14 8 Ds and 4E, this is 10E, for making the required number of Bs, and 10E will be used remaining, that means 6 Ds and 6 Es will go for remaining number of Cs. So, this is the first important requirement for our material requirement planning, that we should be clearly able to spell out that how many components we need. So, we need in this case 14D and 10 Es, so that we can make 1A. For making 1A, you require these many Ds and Es, and then these Ds, Es will make another sub assembly, that is B and C, and those sub assemblies will finally be assembled for making our A. So, this entire process is the input for my material requirement planning, because at some time I will get D and E, those Ds and Es will help me in making intermediate assembly, that is B and C, and those intermediate assemblies will be used in making A, and that entire backward calculation we will see in our upcoming classes, that how are we going to do these calculations in a very systematic. So, with this we come to end of this video. Thank you very much.